Greetings! In this video, we'll introduce the Data Lakehouse, a rising and versatile data architecture. We'll explore Onehouse, the fastest path to a complete data lakehouse solution. And we'll reveal the universal architecture with Delta Lake, Iceberg, and Hudi interoperability through Onetable, providing access from Snowflake, Databricks, Redshift, and many other tools and performance accelerators. Until recently, data warehouses and data lakes have been the go-to solutions for data management. Data warehouses provide a central place to collect well-structured business application data to support business reporting, dashboards, and analytics. Data lakes offer flexibility in handling less structured data in the large amounts needed for data science, including machine learning, in a way that is cost-effective and scalable. Each solves an important part of the overall data problem. However, these architectures aren't able to keep up with modern demands, like high-velocity data streams, and worse, lead to poor data quality because of all the copying between data silos. More recently, the Data Lakehouse has emerged as a more efficient and flexible solution, combining the best features of data lakes and data warehouses into a single converged architecture. Some of the key attributes of data lakehouses are that they are built on cloud-native services, making them both highly elastic and cost-efficient. They typically utilize a distributed file system for scale, with columnar storage, metadata, and indexing for fast queries. They provide for both data governance and data quality, but with flexibility to handle structured, semi-structured, and unstructured data. In short, data lakehouses sidestep past limitations by building on best practices and providing a more versatile and future-proof solution. Before the term data lakehouse existed, engineers at Uber created the first transactional data lake. It was later released as an open-source project in 2016, and Hudi is now a top-level Apache project in a new emerging technology category called the Data Lakehouse. Hudi pioneered the concept of a mutable data lake. By isolating data writes from data reads, Hudi's services layer can scale to thousands of cores. This makes inserts, updates, and deletes to the data lake fast and efficient, allowing it to easily handle data changes, out-of-order data, and duplicate data. One of Hudi's first principles is openness. Open data and metadata formats allow teams to choose storage, ETL tools, query and analytics tools. What is not so common among open-source standards is that Hudi also implements a robust set of services to manage data versioning, ingestion, clustering, compaction, and more, all in open source. Contrast this with systems where your data must be uploaded to a vendor's proprietary storage, where you're locked into their formats, their services, and their tools. Traditionally, streaming data and batch data have required separate workflows. This has meant different tools, separate programming, and extra data copies. However, Hudi's support for data mutations in the data lake unlocks a new paradigm: incremental data processing, capturing data changes from any sources, applying incremental updates to the data lakehouse, and finally unifying the architecture into a single workflow. This is a fundamental shift in data management, providing a universal architecture for all your data. Now, building a data lakehouse and an incremental workflow is a big undertaking. With a team of data engineers, architects, operations, and security experts, it can take 6 months or even more. That's why we built Onehouse. Onehouse is a managed, cloud-native, no-compromise data lakehouse that gets you up and running fast. Getting started with Onehouse to create a new data lakehouse is easy. The first thing to do is to link to your organization's cloud account. For this example, we will be using Amazon Web Services, and we'll assume that you've already created a virtual private cloud to hold the storage, networking, and security policies for your data lakehouse. Next, we will create our data lake inside of an empty S3 bucket, and then create a database, which is a container for a group of tables. Note that all data stays in your account. You maintain the security and control. Before we set up our data sources, it's a good idea to set up our data catalogs. This will allow Onehouse to write metadata to different external systems, such as BigQuery, Databricks, or Snowflake. For example, let's set up an AWS Glue catalog, which will open up our data lake to all Amazon Web Services. We can also use the new Onetable feature. Onetable unifies access to data lake table formats, such as Delta Lake, Apache Iceberg, and Apache Hudi. It creates a universal data lake for Snowflake, Databricks, Redshift, BigQuery, and others, with no need to copy or move data. And Onehouse is collaborating with the open source community to release Onetable as a new open source software project. Let's create a new Onetable catalog so that any data structures that are managed by Hudi will also include the metadata for Delta Lake and Iceberg. We'll use this metadata later in the demo. Now we're ready to set up sources of data. Data sources can include databases, files, and Kafka clusters. Let's connect to a Confluent Kafka cluster containing retail point-of-sale data. For Kafka sources, we set the broker URL, which, in this case, we can grab from Confluent, and then check the message type and paste in the broker credentials. Next, we supply the schema registry endpoint from Confluent and paste in the registry credentials. Having connected to a data source and a catalog, we are ready to create a stream capture, which is how we move data from a source into one or more tables. First, we choose one of our data sources. We can choose between the database, file-based, and Kafka data sources we set up earlier. We'll choose the Kafka cluster. In step 2, we can set the stream capture to either append data records to the tables to keep all the data for further processing, or merge in updates and deletes to keep the data lakehouse in sync with the database. We can also set how often to capture new data. We can discover Kafka topics and configure them all from a single page, or set them up in bulk using the API. Now let's configure some additional Onehouse features. Pipeline quarantine ensures that records that don't fit a schema or that fail a data quality validation are never lost. This setting determines whether bad records are written to a quarantine table or if the pipeline should error out. We can apply transformations, including filtering, flattening, and data masking for security. Multiple transformations create a sequence. We can selectively parse JSON and break nested structures into separate tables or flatten them into a single table. Data validation can be added, for instance, to validate the incoming data against a schema. And finally, we can choose the record key fields or keys for partitioning or sorting. Next, we choose where the data will land in the data lake and which data catalogs will be updated. For example, we can add a Glue catalog, exposing the tables to the whole AWS ecosystem, or add the Onetable catalog we created earlier, making the tables available to any query engine. Now that the data streams are all up and running, Onehouse lets us monitor the data and services activity. Here we have the stream activity, showing the records captured over time. And we can drill into the data table, and, if permissioned, see a preview of the stored records. We can also see statistics such as the table and partition sizes and the insert and upsert rates and bytes written over time. Onehouse also exposes views of core Hudi services such as clustering, which organizes and combines the data in storage to improve query performance. Compaction, which merges incoming data into the existing data to improve write performance. And cleaning, which deletes old data that is no longer needed for time travel to reclaim storage space. Save points are point-in-time snapshots of a table that we can later restore. And finally, the History tab lets us see details of all operations on the table. Now that we have built our data lakehouse, here shown in S3, we can query it using any query engine, for example, AWS Athena via the Glue catalog. A data scientist can explore the data in Databricks via the Onetable Delta Lake compatible metadata. A data engineer can build advanced transformations directly against the data lakehouse using dbt. He can then leverage the Onetable Iceberg compatible metadata in tools like Dremio, Snowflake, and PrestoDB. And end users can run dashboards, reports, and ad hoc queries on nearly any platform, shown here using Mode Studio against Amazon Athena. All these users and use cases are able to work off one copy of the data with universal access through Onetable. Keep in mind that Onehouse is secure and enterprise-ready, having passed both SOC 2 Type 1 and SOC 2 Type 2 certifications. It's important to note that data is never moved from your cloud account or exposed to Onehouse or any other third party. We prevent exposing sensitive data because you maintain the security and control from within your cloud environment. We invite you to bring us your toughest data challenges. Onehouse provides your team with a fast, fully managed, universal data solution that's simple, cost-effective, future-proof, and free from vendor lock-in. Sign up for a free trial today and check out the future of data management at onehouse.ai. Thanks for watching.